Dobry din. That's it with my Russian. I'm sorry for that, so I have to talk English. I would like to make some remarks to the last question, which was presented to Carsten Hein about the level of BIM implementation in Germany and how much organizations or the government is involved in that. Maybe I can clarify a little bit more on that. You quoted our ministry, or Minister of Buildings, Barbara Hendricks. We have the situation currently in Germany that building activities, any kind of structures, they are, from my, as an engineer's perspective, unluckily divided in two ministries. So there is the Ministry of Infrastructure, Digital Infrastructure, and the Ministry for Buildings. And sadly, they are headed by ministers from different parties. So they might not immediately agree on what they do. So we have the situation that the Minister of Infrastructure, mainly dealing with bridges, railway structures, thank you. He is quite keen on improving the way we organize huge projects, and there was a committee on large projects. You maybe heard about this little problematic airport in our capital, Berlin, and people are not satisfied how this project develops, and they fear that the German construction industry will make itself ridiculous. So there is a very strong interest in improving the way buildings are done, are planned in Germany, and this commission to review huge projects, they came up with some very basic ideas how to improve a building or building process, and one thing is plan before you build. It's simple and straightforward. You should not build and plan at the same time. So there's a huge interest. There is political interest into it, but we don't have laws on that. So there's a plan to implement level 2 BIM. So when we talk about the BIM maturity plan, level 2 BIM means every discipline has his own BIM model, and it ought to be in 2020 for infrastructure projects. So let's see whether this time schedule can be maintained, but that's the plan. And I heard signals of Mrs. Hendricks that also the building ministry is interested of implementing BIM workflows and foster this activity. The second remark I like to make is about the question what association of engineers or any professionals are involved in providing regulations or standards for BIM. The answer is there are various of them, and most of them are non-governmental organizations. There is one which is almost governmental. It's called Building and Planning 4.0, Planen und Bauen 4.0. They are trying to implement and help people implementing BIM process. And there's a lot of associations like the Association of Engineers, VDI, Verein Deutscher Ingenieure. They are working on a document about how to implement BIM workflows. So there's a lot of activity going on, but we are not yet at the level of detail or level of jurisdiction you might have in, for example, the UK. So thank you for allowing me to make these remarks in the beginning. I would like to start with my presentation now. And my presentation is a little bit more asking questions. So we as engineers, I think we should be very good at asking the right questions. So I think for us as being responsible to develop this SOFiSTiK products, we sometimes forget to ask questions. So we think we have a very good product and it will sell himself because you engineers immediately understand how to model something, how to analyze something, but we often forget that you as a user, the most important thing for you as a user is to understand the structure. So the real work is done in your brain and not in the software. The software is a tool. So, and that's very important to me, that the software is a tool, it has to be convenient, but the intellectual challenge and all things which are important for building structures at the end are in your head as a structural engineer. I'm trying to outline some problems I think we come across, especially when we talk about BIM in the context of structural analysis. And I think it's two very simple things, is that if we think about how we do structural analysis at the moment, or structural analysis and code checking, we have different tools. And of course, I would be happy if it is SOFiSTiK, but in reality, it will not only be SOFiSTiK. It will be a spreadsheet, it will be a hand calculation, or any other software. So the very important thing is to coordinate these tools. You as an engineer have to coordinate them. And very importantly, for most of the projects, you would look for simplification to understand the structural behavior. Of course, it is nice to look at the 3D structures and the full building model. And of course, you need it for seismic analysis. But if you start probably with a building project, you might simplify. You might break down structural elements. But the thing is that we, as structural engineers, we are influenced by these new digital planning methods. So on the first glimpse into the new BIM workflows, we see ourselves being, maybe the first time we see ourselves as being a small part of the whole building process. And that can be quite challenging to understand that you as a structural engineer, you have some neighbors in the process, you're not alone. It's a very important thing, and I think we should not misunderstand building information modeling as improving our competence in a vertical way, so being the better seismic specialists, being the better structural engineer, being even better in calculating whatever difficult task. BIM means you have to look left and right and see who is the one providing data for you, and on the other hand side, to whom are you providing data? That is BIM. So BIM is teamwork. And even, I think, for us as structural engineers, we usually tend to not be the most communicative persons. We know we have this neighboring discipline, the architects, they are much better in marketing and talking about themselves. We should learn from them, because communication at the end is what makes our construction or our buildings better. So if we look at where we at as structural engineers, we are just a small part, as I said, in this BIM workflow, in the big BIM workflow I might call. And I like to focus on BIM aspects for us as structural engineers. And very importantly, when we think about simplifying, breaking down a building into several parts, we break with the data flow of BIM, because BIM might mean that we have one unique data or one unique representation of the building, at least one for us for the structural analysis, if we think of level 2 BIM. So when we take a spreadsheet, when we take like just a column analysis program, we remove data in our head, so we break with the workflow, so we lose the whole benefit. So we start to work as specialists and forget about our neighbors. So very importantly, I think we have to leverage this positive aspect of BIM. And I like to just ask or show some questions which might be important for software in the future if you want to apply this software as a tool in BIM workflows. And I think the most important thing is, first of all, to think about what is the design workflow in structural engineering. Just a very brief recall. We have a physical model. We saw that in Carsten's presentation. Physical model is the volume, maybe like the architect sees the building without the fancy visualization. We have the structural model, so probably with loads, already with simplifications, because usually we do not do a volume element analysis for a volume, because every real structure is a volume. We simplify, we make beams, shell elements, slab elements, and we put loads on our structure. Then we have our tool of choice, in this case SOFiSTiK, for analyzing deflections, forces, whatever we are interested in for this structure. Then we think about the construction method or the construction type or the material. In this case, it's a reinforced concrete slab, so we think about required reinforcement, we think about how we put the reinforcement in there, and we like to compare required with existing reinforcement, for example. And at the very end of the process, for us as structural engineers, is probably a 3D model of the reinforcement. So I think the most important question which comes into our mind when we think about BIM models, having 3D models, is, does it mean for us as structural engineers that we have to do a 3D analysis for every structure? So does BIM force us to do a 3D analysis? I use a similar example. You maybe have seen it with Carsten's presentation. It's a simple building. I will explain a little bit more about the building later. But I like to illustrate, of course, there is a software which can transfer the physical model into a finite element model which can be calculated. If you do the right modeling and choose the appropriate settings, you will have a structure which you can calculate. But of course, doing 3D calculations is challenging because you have to, as an engineer, to understand the results. You have to trust the results. And clearly a 3D analysis is more results than a simple analysis. So my first question is probably, how can we, if we want to simplify, how can we simplify and choose what I call submodels to be still connected with the full BIM model and give us the flexibility of this detailed investigation. So some examples here. We have a slab of this building and we take the features of the SOFiSTiK FEA extension to extract this slab, to put boundary conditions on the slab which correspond to the stiffness of the connecting elements, and do the analysis for this slab separated from the 3D building. Very important is, if you separate from the building, you have to make sure that if the building or the physical model, the digital physical model changes, you have to think whether you have to update the extracted model or whether it can be done automatically, or you say, I neglect these changes. I think you can imagine that the same holds for a frame structure or a beam structure within this building. It's the same problem. If you want to analyze the detail, if you extract it, how to match the changes which are very likely happening in the design process. So in this slide, I think about collecting the possibilities for doing building or structural analysis. I might call it level of detail for analysis. I don't want to bring in a new abbreviation, but probably that's something we could think about. So we have the building, and there are several ways of calculating it properly. And from my point, I now neglect probably a seismic assessment, which would mean we should start with the 3D model, and a 2D simplification is not feasible. But just thinking about classical structural analysis without seismic, we think of the 2D submodels with a manual load transfer as the basis for all considerations. I might make a small remark, especially as this basis for all calculations, the 2D submodels with the manual load transfer, is widely trusted because it is used by experienced engineers for a long time. It will be something which you always can rely on in discussions. And I think that's also something which is important, because in a lot of building projects you might have an independent checker or even some advisors who like to ask why you choose this model. And very likely, and I'm not saying that this is the right way of modeling, because there is no right or wrong in our profession, or not very clear right or wrong, we will have this 2D base analysis as the basis for all discussions. Then we have the 3D model, which is clearly a full 3D finite element model of the building. We have seen an example before. And then, if you have experience with buildings, and I know a lot of people in this room have, you know that a building is not produced like that. So the building is there. So you build it story by story. So what about simulating this building process? Does it affect the forces? It does. And even more, when we think about the material, and if the material is, for example, concrete, we have time-dependent effects. So we might think of enhancing our analysis towards construction stages, time-dependent effects, and so on. The question is, does it help us? Does it make the building better, or does it give a better building for the client? So my question is, you have to decide, or my idea is that you as an engineer has to decide what you want to do. And at the end, the software should help you, but at the end you should decide what way or what level of detail you're using. So on this slide, and I will not go through all the details, I like to show a little numbers and a little illustration of the size of such effects, the differences between a 3D analysis and a 2D analysis, or even a more complicated analysis. And I show this building we have already seen on Carsten's presentation. It's a very simple building. It has self-weight, it has live load, but there is no additional loading on it. Just to make it very simple, we have a self-weight load case and a full live load case. So no load patterning, nothing in addition. We neglect snow and wind, and we clearly see that this is a reinforced concrete structure, because a reinforced concrete structure most of the time carries itself. This is clearly not a lightweight structure. So most of the time this structure is doing work and carrying itself, and it's just a minimum level of live load in it. And for this, I think, quite realistic standard building, I like to investigate the results for different elements. I have to point out that when we think about 3D models, it might sound very simple to extract a 3D finite element mesh from a BIM model, but there is a lot of attention to detail required. So for example, from my point of view, the most important thing is for this building that the slabs are not rigidly connected to the core walls. And I think it will very often be the case that this is not wanted, because you don't want to reinforce, you don't want to construct the slab that it is cantilevering out of the core walls. So you need to have an intelligent software allowing you to define proper hinges. Same holds for columns. Da, spasibo. The same holds for columns. You all know that for columns this effect is not as large. And now we look at some of the results, and it's not important to discuss the results in detail. It's just interesting that for such a simple element as a column in a simple building, the different ways of modeling it, from the simple 2D to a fully 3D with time-dependent effect analysis, differs of larger than 10% in results. So you see there on the left-hand side, there's the calculation with stiff interconnections, and that's the calculation with hinged interconnection. So not a big difference, but already quite significant. If we look at bending members, and this is still a beam member, so it's not a slab member, so you see that there are huge differences in the results for this downstand beam. So what I wanted to say is, I'm not telling you what is the correct result or what is more realistic. Nobody really knows. But it's a very interesting insight to know the variance of a result. And I think a good software should give you the possibilities to investigate that. So my conclusion, the classical 2D submodels give the most conservative results. So in a classical load transfer, I think it would be a good starting point to be on the safe side, but I'm not talking about complex building structures. Of course, 3D finite element analysis needs a careful consideration, and from my point of view, it is more important to consider the appropriate inter-element stiffnesses than to go into more involved calculations like time-dependent effects, because at the end of the day, creep and shrinkage of concrete equalizes these effects. So I think we should, instead of complicating the analysis, we should think about a tool which gives us a good starting point for any further analysis and considerations. So this will be, I think, explained in the following presentation. So I think there is a need for intelligent 2D submodels within the BIM workflow, and we should think of that BIM means data exchange to all kinds of tools. Спасибо большое.
Спасибо, Стефан.
Thank you, Stefan.
Прошу не уходить.
Please don't go away. If you have questions, please name yourself, and you have 30 seconds to ask your questions.
BIM Machine. Mein Deutsch ist nicht so gut, so ich will auf Englisch fragen. So my question is, SOFiSTiK has a pretty good connection with Revit. Revit is preparing the new project called Quantum, a SaaS thing that will be a software that will moving Revit to the cloud. So now Revit is desktop app and SOFiSTiK is desktop. So are you getting prepared to the SaaS revolution? Thanks.
Thank you. That's a very interesting question. So, as I said, I was only focusing on one structural engineer sitting at a desk with one project. I was not talking about collaboration and things, but I appreciate the question, and we are considering these advances, and we are currently investigating possibilities of performing a structural analysis in a shared way, so that you don't need so much computer power on your desktop. And on the other hand side, we are, but that's rather talking to Autodesk, trying to find out what they do with collaboration for models and viewing BIM models in the cloud, especially from a structural engineer's point of view. Thank you.
Пожалуйста, спасибо. Еще вопрос?
Представьтесь. Андрей Ашанов, проектное бюро Apex.
Andrei Ashanov, Apex Design Bureau. The question is about interaction with Revit. SOFiSTiK has excellent collaboration with Revit. The only thing is that in version 17 of Revit, we have analytical surfaces, and now we don't have any calculation software which can interact with such. You have experience with interaction with Rhino. Do you plan any interaction of this kind of things with Revit?
More complex surfaces in Revit.
Yes, surface.
And for structural analysis. Yes. Of course, yes, we would be interested in supporting anything which is possible within Revit, and we are in discussion with Autodesk about possibilities, but I cannot say when this will happen, but definitely it's interesting. So if it's possible in Revit to use that, we will do. And maybe I can ask Armin in the following presentation if you have some remarks on this question. please just give your opinion.
Узнаем в процессе выступления.
So we shall learn in this next presentations about such things. Any more questions? No questions? I have a question to you. Stefan, please tell me, in your presentation you mentioned software parameter as the time parameter, long-term time effects. Do you calculate them in Germany in terms of quality of German concrete? But the German productivity is quite different from Russian productivity and quality. What shall we do here? Can we, in your software, adjust it to Russian specifics?
Thank you for the question. I think the answer is yes. You can adjust the basic creep and shrinkage model to any kind of material. The question is, does it make sense? So, for example, this is also something which is often forgot in Germany, and there was happening some problems because people neglect that the Young's modulus of concrete varies with the stiffness of the gravel in it. And people forget it. They read the Young's modulus in the code and they think it is there, but nobody told the concrete. So that's an important thing. From my point of view, yes, you can adjust. Problem is you have to think about how to adjust the model. And I would say it might be more interesting to do it, so at least try two different stiffnesses to see what the effect is, instead of asking what is the right stiffness. See what the effect is, and maybe the effect is negligible because you have such a robust building, so you can stick with the classical 3D analysis.
Маленькое уточнение.
I was told by your Swiss colleagues that there is a piece of software which controls the work time of an employee. How long does he stay at work? Have you got any such software to control the work time?
Поблагодарим Стефана.
Thank you, Stephen, for an excellent presentation.